Hi, and welcome back to the last video on Chapter 3, Vectors. We're going to finish up vector multiplication with the cross product. The cross product yields a vector. So A crossed with B, both vectors, are going to yield a vector. The magnitude of that vector, which we're going to call just plain C, is the product of the magnitudes of the two vectors A and B times the sine of the angle in between. Remember, dot product was cosine. Okay? That's the magnitude. The direction is perpendicular to the plane. Well, that was weird. To the plane formed by the two vectors A and B. All right, so let's look at that. So if we have, let's call this right here. We're going to call this vector A here. We're going to call this vector B. And in between, we have this angle theta. Then C is perpendicular to the plane formed by these two vectors. So a way to think about this, because it's kind of abstract, but the way to think about that in a practical way is think about a fan. Think about a fan that's rotating. The blades are rotating in this AB plane, but the air is being blown in a direction perpendicular to the fan. Okay, so you have the right-hand rule causing the rotation, and the effect is coming out perpendicular to it. Right, so again, this direction is given by the right-hand rule. So I'm going to write a brief description of that here, and I'm going to give you a reference in your book where they go into it in some more detail. So in the right-hand rule, you place your hand flat with fingers pointing along vector A, whatever the first vector in the cross product is. Here it's A. Then you rotate your wrist until it is possible to curl your fingers, which are outstretched, from the direction of vector A to the direction of vector B. And once you do that curl, your thumb points in the direction of C. So there's your hand outstretched. Okay, and so I'm going to put that in the direction of A. So I'm rotating my wrist until I get it in the direction of A as shown on my diagram here. And then my fingers then curl in the direction of B. So they're curling in the direction of B, and C is the way my thumb points. If it was B cross A, I would be going in the direction of B, but I can't curl my fingers towards A, so I'd have to turn my hand over in order to curl my fingers from B to A. All right, and then when I did that, C would be pointing downward, the opposite. All right, so that's telling you that B cross A gives you a different result than A cross B, and it actually is the negative. So, well, before I write that, let me give you the reference in your book. So, for right hand rule, RHR, see text, pages 84 to 85, for some illustrations. Okay, so let's do our cross product summary like we did for dot product. Okay, so let's see what we got here. Okay, first thing on our summary is A cross B is not the same as B cross A. It's the negative. It's like negative B cross A, as we just saw when I worked out the dot product for that, right? So if you change the order of the vectors, the sign of your result changes. The magnitude doesn't, but the sign changes. Also, similar thing, A crossed with a minus B, it's going to equal minus A cross B. And A cross A equals 0, because sine of 0 is 0. Okay, so that's the first set of properties of the cross product. Number 2, if A is parallel to B, vector A is parallel to vector B, then A cross B equals 0. That's kind of what we said in number 1, but it's good to be explicit. Number 3, if A is perpendicular to B, then A cross B, at least the absolute value, the magnitude of A cross B is going to equal the full magnitude of A times B, because sine of 90 equals 1. Number 4, the cross product obeys the distributive law. So, what does that look like? So if you have A crossed B plus C, the quantity, this is the same as A cross B plus A cross C. If you don't believe it, try it out. It's always a good thing. And then unit vectors. Exactly the opposite of what we had for dot product. So for unit vectors, So when the unit vectors are the same, I cross I is the same as j cross j, is the same as k cross k. All those are 0. Whereas for the dot product, they are all 1. Now, I cross j is 1. Notice the order. J cross k equals 1. K cross I is 1. Okay, so it's like a rotation. I to j, j, k, k, I is 1. Now, if you reverse those orders, you get a negative 1. Right? Remember, the negative of the cross product, are reversing the order of the vectors creates a negative. We saw that just a minute ago. So the opposites of these, j cross I, is a negative 1. K cross j is, oops, forgot the negative, negative 1. And I cross k. The one people most likely make a mistake on is I cross k, because I is like the first one, the x. So sometimes that gets confusing. All right, so let's mess with one of these. We're going to take a vector A that equals 2i plus 3j, and another vector B that is minus I plus 2j. And we want to find a cross product. The first thing, find A crossed with B. All right. So I'm just going to draw a little sketch over here. This is a 2D problem. Just so we know that A is going to be over here. We know that B is going to be on this side because it's a negative, right? We've got negative sign here. So B is going to be over here. Okay, so it just helps us keep that in mind, what we expect. So A cross B, A crossed into B, is going to be coming out of the paper as we see it, the direction. All right, that's what we would expect. So let's do this. A cross B is 2i plus 3j crossed with minus I plus 2j hat. Okay, so first thing we're going to do is take this 2i and multiply by this minus I, and that would give us a 0. Now if we take this 2i and multiply by this 2, we get 4. Oops. You know what? I'm skipping a step here. And I don't think that's a good idea. So let me back up here a minute. All right, so write this down again. Okay, so we've got 2i plus, 2i cross 2j plus 3j cross minus I. Okay, So just to be clear about how we got that, this crossed with this is this term here. And when you cross these two, right, they're in the same direction. So those two are 0. You do the same thing with the 3j. When you cross it with the I, okay, you get 3j cross minus I. When you take 3j and you cross with 2j, it's 0. So that's why you end up with this. And then we just simplify using our rules. So this is 4. And for direction, I cross j. This is plus a minus 3 times j cross I. I cross j from up here is 1, so this is k, and 4k. And this over here is going to be minus 3 times minus k. So that's going to equal 7k. And I just realized up here, these aren't ones. I cross j is k. J cross k is I. And k cross I is j. I'm sorry about that. That must have been confusing when you saw that. And the same over here, only negatives. All right. All right, we're all set there now. All right. Okay, so in 3D, it gets a little more complicated. 3D component form. So you have a vector A that in 3D is the x component, I hat, plus the y component of A, j hat, plus the z component of j, k hat, and the same with B, bx plus by plus bz. All right, now when you do A cross B, what you end up with is AY BZ minus AZ BY, that whole quantity in the I hat direction, plus AZ BX minus AX BZ, that whole quantity in the j hat direction, and plus AX BY minus AY BX in the k hat direction. Notice in the I hat direction there's no x components. In the j direction there's no y components. In the z direction, no z components. Okay? So, so that's cross product. There are other ways. Oh, one other thing that's sometimes asked. Remember C I'll just give you a heads up with this one. C equals A cross B. And the magnitude C equals AB sine theta. Okay, so sometimes you might be asked to find theta. If you were asked that, that means you need to find the magnitude. Somehow you have to have the magnitude of C and the magnitude of the two vectors that are crossed, and then you can find the angle in between. Okay, so that's all that goes on with that. A cross B can also be done, and I'm not going to go through this right now. I'm just going to set it up. I'm not going to go through how to solve a matrix. Hopefully we'll get to at least one of these during our problem session. But just so you know, it would be the x component of A, x component of y. X component of A, y component of A, z component of A, and then the x component of B, the y component of B, and the z component of B. All right, that's it for chapter 3. Thanks for your patience. This was a little long, this one. So I will catch up with you later this week. All right, bye for now.